Welcome to this class. Today I am going to continue the chapter Wave of Science and Technology of class 9, and this chapter is taken in unit number 10, and this is last part of the wave. And in this part, what we are going to do, we are going to talk about reflection of sound and its uses. Sound reflects like light. There is a little difference between the reflection of sound and light, but we are talking about reflection of sound. Sound also travels in the form of wave motion and light also travels in the form of wave motion. But what about the reflection of sound? Today we are going to study about this and uses. Where is it used? Okay, let's start. Reflection of sound can be understood this way. Let's say this is a source of sound and a sound pulse is produced. Pulse means if I say A, then the pulse of sound moves forward. If I say hello, hello moves forward. If I am continuously talking, then this is not called pulse. The pulse of sound is when produced in front of a hard object, then it strikes the object and reflects back. This surface may be liquid also sometimes. Sometimes liquid surface also reflects sound, but we are concerned with hard solid object for the better understanding of the reflection of sound. Here, the reflection of sound is shown in terms of pulse of sound. How light reflects, in the same way, sound also reflects. Okay, but we have a little problem. Sound wave cannot be seen. Air particle carries sound wave in the form of compression and rarefaction, which cannot be seen. That's why we have problem to understand this. Even after this, we can define sound, reflection of sound this way. The bouncing back of the sound wave after striking a surface is called reflection of sound. We can understand this way also. We can show this diagram also. Look at this is a source of sound. And if sound is being produced towards this object, this plane surface, then what happens? Let's say sound wave traveled certain distance up to this object, and when it strikes this surface, then it reflects back like this. And if we plot a normal in between them, then this is incident sound, this is reflected sound. Like light, sound has also incident sound and reflected sound. This way, the bouncing back of the sound wave after striking a surface is called reflection of sound. Now let's talk about effect of reflection. There are two major effects of reflection of sound. One is called reverberation. In Nepali, we say gunjan. And another is called echo. In Nepali, we used to say pratidhwani. Reverberation and echo are the best example. I mean to say, there are two major effects of reflection of sound. One is reverberation, another is echo. Now, what is reverberation? I want to tell you about something other than this word. If you are in a room and the room is empty, newly made room, nothing is there. I mean to say, no curtain, no furniture, no any cloth at all. It's completely empty. And if you enter in that room and if you say A, then have you noticed that? The same A becomes a long drawn effect of sound. If you say hello, then it becomes hello, something like this. The long drawn effect of sound can be heard over there because of the reflection of sound waves by the walls of the room. And that's why we can define this way. The long drawn effect of sound due to the reflection of sound waves is called reverberation, pratidhwani. Now let's talk about echo. If we are somewhere in between certain hills and hills are near to us and a narrow passage is there, if we make a loud sound like eh, then what happens? The same sound can be heard again. The single sound becomes eh, eh, sometimes more than that, repetition many times. This way the sound becomes fainter and fainter. The reflected sound has to travel long distance, and that's why its intensity goes on decreasing, and the echo sound is fainter than the original sound. And this is also due to the reflection of sound. Now we can say it like this: the repetition of sound due to the reflection of sound waves is called echo. Now, why it happens? This is the science. This understanding is not the lot of science. Actually, anyone can understand that when we talk something in a newly made room, then the reverberation occurs. If we say something loudly nearby the hills, then it will be repeated. This is normal matter. We don't have to come to class 9 to understand about this. But what is the science behind this is the important part. We have to understand why reverberation occurs, why echo occurs, why long drawn effect of sound is heard in room, why the repetition of sound occurs in certain place. This is the science. That's why I want to tell you something about this. When I say something, just then what happens? Sound wave travels in all the possible direction, towards forward also, towards this direction also, everywhere. And it has the property of diffraction more than light, and it strikes the face and comes to my ear also. When I say A, the same sound is heard here also and moves forward also. And when this sound enters into our ear, it remains for 1/10 second in our ear. Till 1/10 second, its effect can be heard. And let's say, if I say A, then this is the length of the time 1/10 second up to which it remains in my ear, and at the same time, when the A move towards this direction, I mean to say sound wave carrying A move towards this direction, is reflected back by the wall of the room, and it comes within this 1/10 second. Previous effect is not finished. Previous effect of A is not finished, but reflected sound again entered into my ear. Then the same A can be heard for this much long time period, isn't it? And that's why instead of being A, it becomes A. This is the reason. The long drawn effect of sound can be heard in the room. The reason is very simple. Sound wave remains in our ear up to 1/10 second. Within the same time period, if reflected sound also comes and enters into our ear, then the same A becomes prolonged A. I mean to say, long drawn effect of A can be heard. A. This is the reason. This is because of the reflection by the walls lying near to us, near to our mouth, near to me. The reflected sound gives the impression of reverberation. Now, what about echo? Now, let's talk about echo. I want to show with the help of diagram. Let's say someone is standing at a place here, and he is making sound in front of a big wall made up of, let's say, the rock. And if he says something loudly, let's say A, then sound move towards this direction and strike on this wall and returns back because it has the property of reflection. When I say A, then what happens? Original sound enters into my ear. It remains up to 1/10 second. But the reflected sound, if comes to my ear after 1/10 second, then the effect of original sound is gone. So once A is heard, the original sound, and if reflected sound comes to my ear and it comes after the effect of the previous sound, then the same A can be heard twice. because previous effect is finished. Now the reflected sound again gives the impression of A, and that's why A can be heard second time. And this is echo. The repetition of sound due to the reflection of sound wave is called echo. Now, why here we have echo? In the room we have reverberation. There is the clue point, that is time 1 by 10 second. Time 1 by 10 second. What I mean to say, effect of sound remains in our ear up to 1 by 10 second. And reflected sound, if comes later than this, echo. If within this time it comes, then reverberation. Now, velocity of sound in air can be considered as 340 meter per second, because it is 332 meter per second at 0 degree Celsius, but normal temperature of air is not 0 degree Celsius, it is more than that. That's why we can take this average value 340 meter per second. Then if this distance is x, and let's say the sound produced by this person reflects back and comes to his ear exactly after 1 by 10 second time, then what should be the distance between this person and the wall? Now I'm going to calculate that. Velocity is equal to distance by time. Velocity equal to, here sound travels 2x distance while going to this wall or the surface, x, again coming back to his ear, x. It means it covers 2x distance, and time taken to cover this 2x distance is, if taken as t, then we can say that v is 340 meter per second. Let's say 340 meter per second is v, and this is equal to 2x, and time is 1 by 10 second. If 1 by 10 second is taken to left hand side, this is equal to 2x, this is equal to 34, this is equal to 34, 0 0 cancel, second cancel, 34 what? Meter is equal to 2x, and therefore x is equal to 34 divided by 2 becomes 17 meter. What is this? It means if sound reflecting surface is at the distance of 17 meter, then reflected sound comes to our ear exactly at 1 by 10 second. If this surface is far away, I mean to say away than 17 meter, then what happens? Reflected sound comes later than 1 by 10 second. This is the condition of echo. And if this wall or this surface is nearer than 17 meter, then what happens? Then reflected sound comes to our ear within 1 by 10 second. This is the condition of reverberation. That's why we can conclude that if the sound reflecting surface is nearby us, then reverberation occurs. If sound reflecting surface is a little away from us, then echo can be heard. Now this is all about the echo and reverberation. Okay, I want to go to another part. Sometimes reverberation and echo is not desirable. I mean to say that becomes disturbing in the recording rooms, music recording room and studio like this also. And that's why the sound wave which goes to the wall should not return back. Otherwise, it gives a little noisy type of sound. For this, certain material is used for the protection. This is called acoustic protection. Now, exactly what it is, the techniques or the methods we use to absorb undesirable sounds by using soft porous substances, soft porous surfaces is called acoustic protection. Look at these substances. They are porous. There are so many pores, and sound travels in the form of compression and rarefaction, and these molecules are vibrating. I mean to say air molecules are vibrating forward and backward, and when it enters into the pores, then vibration stops, and this is the absorption of sound. Look at this. This way we can understand clearly this source is producing sound when it strikes this type of surface where there are many pores, then sound waves are absorbed in this material, due to which reflection is prevented and undesirable sound is absorbed. I mean to say undesirable sound is removed, and it is done in music recording, it is done in this radio recording, and in this type of studio also. For the absorption of sound waves which strike on the wall, the wall surface of the wall is provided with this porous material, and it is done in television broadcasting also, recording studio also, in the music recording studio also, etc., etc. Okay, now this part is finished. Now I want to tell you about the spectrum of sound, the order of sound, what it is. Actually, spectrum of sound means sound is taken in order. They are arranged in the order according to their frequency and audibility. And this is called spectrum of sound. We can say this way, according to the frequency and audibility of sound, it is arranged in an order called spectrum of sound. What is its order? One is called infrasound or infrasonic sound, another is called audible sound, another one is called ultrasound or ultrasonic sound. How are they arranged in this manner? Why this spectrum is made? According to the frequency and audibility. Now, infrasound or infrasonic sound, its frequency is less than 20 Hz. But audible sound, its frequency is in between 20 Hz to 20 kilohertz. But ultrasound has very huge frequency, high frequency, that is 20 kilohertz. Now I want to tell you about each of them a little. Infrasonic sound and its example. Sound having frequency less than 20 Hz is infrasonic sound. We know about this. Just before this I told you about this. Sound produced during earthquake and volcanic eruption is infrasonic sound. When earthquake comes, then the surface of the earth rim begin to shake, and this shaking may be horizontal or sometimes vertical also, sometimes curvical also. At this time, sound produces, but we are not able to hear that sound because its frequency is less than 20 Hz, and if frequency is less than 20 Hz, we cannot hear that sound. And another example, whale, elephant, rhino, hippo, octopus, pigeon, etc. produces infrasonic sound. Now, what is told? The herd of the animal, they communicate with each other by means of infrasonic sound. Some of them, like elephant, rhino, hippo, etc., they communicate with each other by the help of infrasonic sound. Now let's talk about another audible sound. What to say about audible sound? This is very simple. Sound having frequency more than 20 Hz and less than 20 kHz is audible sound. The sound which can be heard is audible sound. Whether it is the sound of the aeroplane, or it is the musical sound, or if someone is playing guitar, or somewhere there is bomb blast, whatever it is, the sound which can be heard may be very faint, may be very loud. All these are under the audible limit. So the audible sound means the sound having frequency 20 Hz to 20 kilohertz. Kilohertz means 20,000 Hz. Okay, now let's talk about ultrasonic sound. We are going to focus on ultrasonic sound later. Ultrasonic sound and its example. The sound having frequency greater than 20 kHz is ultrasonic sound, which cannot be heard because its frequency is out of audible limit. We cannot hear this sound. And it can be produced by bat, dolphin, etc. Bat and dolphin. There is a saying that bat can see at night. It's a little wrong idea. Bat cannot see at night. But what happens at night? bat produces ultrasonic sound having frequency more than 20 kilohertz. It can produce the sound having frequency 100 kilohertz also. And this ultrasonic sound is released by the nostril cavity of this bat. And when it moves forward and strike the prey, then it reflects back from that prey. I mean to say, the reflected sound comes to bat again, and the bat will be able to locate that. This is called echolocation of sound. With the help of ultrasonic sound, which is reflected back by spray, the prey can be detected by a bat, and bat can attack that prey. Not only this, if a bat is moving towards this direction, there is obstacle, maybe a pole or maybe a tree or something, then because of the reflected ultrasound, the echolocation, it can understand that there is certain object, and so it can fly this way, going away from that obstacle. This way, echolocation, by the echolocation, this bat can attack the prey and it can move away from obstacle. Now, dolphin also does the same thing. Look at this. Dolphin releases ultrasound, which when it strikes the fish, then it reflects back, and reflected sound can be absorbed by dolphin, and because of this echolocation, it can attack the fish, it can eat the fish. This is the working mechanism of ultrasound produced by bat and dolphin. Okay, echolocation is the active detection and identification of the object using echoes of ultrasound to avoid or capture the target. Either it avoid the target, moves away, or it capture that target if it is prey. Okay, now next, dog and cat can hear ultrasound. Have you noticed that sometimes a dog sleeping at certain place, all of a sudden it raises the head and it starts barking and moves somewhere? What is happening to the dog? Maybe certain ultrasound is heard, and because of that reason the reaction came. This way, dog can hear ultrasound of 45 kilohertz or more, and cat can hear the ultrasound of more than that frequency, and this is their speciality. Now, this whistle, I want to introduce this. This is called Galton whistle, made by a person, Galton. That's why called Galton whistle. And this whistle is, if blown, then ultrasound produces, but sound cannot be heard. This is not audible to human. But when this whistle is blown, then dog comes near to the trainer. Trainer usually use this Galton whistle while taking many dogs in open place. The trainer teach something to particular dog, and some of the dog may be moving away from that place also. Whenever he has to collect them, he blow the whistle, and the dog comes to him, and they can be again trained. This way, Galton whistle is used by dog trainer. It is also used by the dog owner also. If we have very huge surface area, I mean to say huge area around the house, dog is somewhere far away, and it's food time for the dog, then the dog owner will blow this whistle, and this whistle produces sound, but we cannot hear that sound, and it can be heard by the dog, and dog comes to its owner to get the food. This way, this Galton whistle is used to collect the dog or to call the dog, etc. Okay, now we are talking about ultrasonic sound. Now I want to introduce this sonar. What it is? Sonar technology. What it means, sonar? Actually, sonar means sound, SON, navigation and ranging. sound navigation and ranging, SONAR, full form of sonar, SONAR, is sound navigation and ranging. And what it means, this technology is used to find the depth of the sea. How? I want to tell you a little more. Let's say this is a ship moving in the sea, and this is the depth of the sea, the seabed. And there are two machinery parts. One is called transmitter. I'm writing just T for transmitter. And another is called receiver. This sonar technology emits ultrasonic sound to the seabed, and when it strikes the seabed, then it returns back and can be received by this receiver. Sound first has to go to seabed and is reflected back to the same place and is absorbed by this receiver. And what is the time taken by the sound to be absorbed again is calculated. And if it is 3 seconds, let's say it takes 3 seconds to go up to the seabed and come back to the receiver, then time taken by the sound is 3 seconds total time. The distance covered is 2x. Let's say this is the x is the distance to go up to the seabed, and x is again the distance from seabed to the this receiver. Then this is water where sound is traveling. Now, velocity of sound in water is about 1500 meter per second. Velocity of sound in water is 1500 meter per second. And what is written here, time is equal to, if 3 seconds is taken by this sound to go up to seabed and come back to this receiver, and distance traveled is if 2x, then using the formula V equal to d by t, we can calculate the depth of this sea. How? This is 1500 meter per second, and if this t is taken to left hand side, it is 3 seconds. 3 seconds is equal to d, and this is equal to 4500 meter per second. Second cancel, 4500 meter, and distance is 2x. That's why x is equal to what? Therefore, x is equal to 4500 divided by 2 becomes 2 2s are 4, 2 2s are 4, 2 5s are 10, 0. The depth of the sea is calculated 2250 meter. This way, sonar technology is used to find the depth of the sea. Now let's move forward. Ultrasonography. What is it? Ultrasonography is a type of medical imaging that use ultrasound to produce images of internal organs and other tissues. And normally we used to say video X-ray. This is not X-ray. X-ray is different electromagnetic waves, but ultrasonography doesn't include that. It is sound wave. And that's why I'm talking about the ultrasound. And how do we do this? I mean to say ultrasonography. At first, the patient has to lie on a table, removing clothing from the area that will be examined. This lady is pregnant lady, and she is going to examine the condition of the baby in the mother's womb. And she has to lie over there, and then a gel will be sprayed by the sonographer. This is called sonographer, maybe doctor, or maybe just the assistant of the doctor, sonographer who is doing sonography. So a gel will be sprayed by the sonographer on the skin of patient over the area that will be examined. The sonographer will hold a device called a transducer and move it across the skin. The device sends ultrasound into the body. this device appears like this, and this sends ultrasound. Actually, electrical signal converts to ultrasound and sends into the body, and it is targeted towards particular part of the body, and when it is strike over there, then it is reflected back. This is ultrasound reflected back by that particular organ and comes back to this transducer, and transducer receives it and again converts to electrical signal, and this electrical signal is taken, this transmitted from the transducer through the gel into the body. This short burst of sound energy hit the desired organ and return to the probe as an echo. The probe diverts them to a biometer present in the system. Now this probe diverts this to the biometer, and the biometer converts the sound wave data into the image, and this image is called sonogram. Ultrasound image is called sonogram. Looking at that sonogram, now doctor can identify the condition of the particular organ, condition of the baby, of the mother's womb, whatever they are examining. Okay. Now let's move forward. This is the 3D image of the baby of the mother's womb. It can be understood nicely by the doctor how this baby is, its health is okay or not, its organ is functioning quite well or not, etc., etc. Now, uses of ultrasonography, for what purpose it is used? Stone of gallbladder and kidney, tumor of brain and pancreas, liver disease, uterine disease, intestinal problem, etc. can be checked by using ultrasound. Now next, it is used to check size and condition of the fetus, the motion of the organs and its abnormalities, if any. If there is any abnormalities, that can also be understood. The condition of the fetus can be observed more clearly by 3D ultrasonic technology. It is also used to check heartbeat and condition of the valve and their function. This technology is called echocardiography. Okay. Now let's talk about some other matter. This is X-ray imaging. They're very famous. You know about this. We are doing X-ray frequently. I mean to say, some person if have certain fracture in his bone, then certainly we have to go through X-ray, isn't it? Now what is X-ray actually imaging? X-ray imaging means it is medical sector is, X-ray imaging in the medical sector is the process in which picture of the inside of the body is created by using X-ray. Picture of the inside body, mainly we are focused on the bone, but not only the bone, actually the X-ray passes through each and every part of our body and it is absorbed a lot by the bone. That's why its image becomes white on the screen. But if it easily passes through the flesh, then it appears black, there is nothing. This way, different organs, connective tissue, bone, they absorb X-ray in different amounts. Accordingly, the image appears different. Now, let's talk about the X-ray imaging technique, how we do it. At first, the patient is positioned in front of the X-ray machine at certain distance. An X-ray beam is then passed through the body for the fraction of a second. Look at this. This is X-ray machine, and X-ray is passed through his body, and some of the X-ray is coming out of his body. Some of them are absorbed by the body. It is shown here, and bone absorbs it, flesh doesn't absorb it, and the air sac doesn't absorb it. And this way, some passes through the body, some doesn't. Now, maybe the patient is lying this way, he may be lying this way, and X-ray is passed through his hand only, because we are focused on hand. He has certain problem in hand, whether the fracture is there or not is going to be found. And this way first the patient is positioned, and X-ray passed through the body strikes the X-ray film placed behind the body of the patient. Here it is. I want to show it. This is the X-ray plate. Here it is taken, and here also X-ray plate is here. X-ray detector is here. The plate is there, and film is taken in this plate. And then what happens? A black and white X-ray film produces according to the absorption of different structure of the body. Different structure means if there is bone, then white part appears. If there is no bone, flesh only, black part appears. Accordingly, the connective tissue produces some certain other, but the X-ray is black and white. It can be seen this way. This is the X-ray of chest. But we cannot understand everything clearly because this is the medical matter. Doctor can understand what sort of disease the person have. We can say that's the broken bone only, not more than that, because this is not our subject. We are just interested with what is X-ray and how it is done. Yeah, what science is behind this X-ray. Okay, now look at this hand. If we have to take the X-ray of hand, then we have to put our hand on the X-ray plate. And there is X-ray film behind it. And when X-ray is passed for a fraction of a second, then it can appear like this. I mean to say the X-ray of the bone can be seen, and this a little white part represents the muscle, and this black represents flesh, isn't it? A little maybe connective tissue. This is the X-ray of left hand, and nothing is seen to be broken. This way we get X-ray. Okay, uses of X-ray photography. For what purpose it is used? To find the fracture of bone or broken bone. Look at this. Here, the bone is broken in this X-ray. The small finger, the bone behind this small finger is broken. It can be understood with the help of X-ray. And next, to check root of teeth. Root of teeth can be, X-ray can take the root of teeth, whether it is damaged or not. If we have to go through treatment, then we'll go through treatment, otherwise not. Here, after is written, it means once treated and again the X-ray is done. And what sort of information is obtained, that can be understood nicely by the doctor, but we are talking about just the principle of X-ray formation. Now next, to find tumors. Now look at this. This is the tumor seen in this bone. This way X-ray is also directed towards tumor. I mean to say X-ray finds tumor also. To find arterial blockage. Arterial blockage can also be found by X-ray. Look at this. This is the normal heart. Here arterial blockage is found. This is here labeled arterial blockage. Now, after all this understanding, we have to be very careful in X-ray. We don't have to go frequently for X-ray. If many times we go for X-ray, then what happens? X-ray is very harmful rays. When it passes through our body, then it damages certain cells of our body, and a very dangerous disease, cancer, may occur. That's why as far as possible, we have to go through X-ray, very special case one. Okay, now let's talk about computed tomography scan. What it mean? We are saying CT scan. Computed tomography scan. This is the long form, and CT scan, we used to say CT scan. What is it? CT scan is nothing more than X-ray. CT scan is the medical imaging technique that shows detailed image of any part of the body, including the bones, muscle, organ, and blood vessels, by the use of X-ray photography. Then what is the difference? There is big difference. This is directed towards particular organ and it produces 3D image, but normal X-ray produces just the photograph only, whether the bone is broken or not, whether there is blockage or not, etc. But this CT scan is done by this donut-shaped machine. Yeah, and the patient is introduced to this machine. This is advanced form of X-ray photography. In this process, the X-ray machine rotates in 360 degree around the patient, and powerful X-ray beam is targeted to the body part which has to be checked, and the X-ray source is rotated around the patient to get 3D image of the targeted part of the body. It can be done this way. We can understand with this animated video. Look at this. The X-ray machine is rotating in CT scan. It is targeted towards particular organ because we are interested to know any fault on that organ or not. And then it displays the result on the screen. It finds the photograph of that targeted part on the screen. This way, the particular organ can be checked nicely. Okay, CT scan is used to check internal wounds, blood clots, tumors, condition of lungs, brains, etc. This is 3D image of CT scan. This is also 3D image of CT scan. What can we understand with this? Let's give this to doctor. They will find, looking at this, they will find the defect. But how it appears only I am showing. 3D effect of CT scan is seen here, but the defect, what sort of defect, whether it is okay or not, we cannot understand this. This will be checked up by the doctor. Okay, now I think time also finished. So I want to finish this class. Today I told you about the reflection of the sound and uses of reflection of sound in different sectors, and with this part, I mean to say this chapter, wave chapter, is finished. Now we'll meet in some another class with another matter. Thank you.